Assalamualaikum warahmatullahi ta'ala wabarakatuh. My name is Muizzuddin Bin Kamarodin. So you guys can call me Teacher Muiz. So let us proceed to the last session for today's lesson, which is acid, base and salt. Alright, so what is acid? So an acid is any substance that in water solution it tastes sour. It changes blue litmus paper to red, reacts with some metals to liberate hydrogen, reacts with bases to form salts, and promotes chemical reactions. So as you can see in the picture, in the slide, we have lemon, orange, vinegar and urine. So this is some example that contain acid. Alright, so now we proceed to the basicity of acids. So basicity of acids, it refers to the number of hydrogen ions that can be produced by an acid molecule that ionize in water. Alright, for monoprotic acid, we have hydrochloric acid, which produce only one hydrogen ion per acid molecule. And for diprotic acid, we have sulfuric acid. It produces 2 hydrogen ions per acid molecule. And last one is triprotic acid. We have phosphoric acid that produce 3 hydrogen ion per acid molecule. Alright, next we proceed to base. So what is base? So base is a substance that reacts with acids to produce salt and water only. For example, metal oxides and metal hydroxides are bases. Alright, and then next we have the alkali. So what is alkali? Alkali is a base that is soluble in water. So when the base is soluble in water, it is called as an alkali. Alright, for example, we have potassium hydroxide and sodium hydroxide. Alright, so as you can see at the slide now, we have some of the example of base. So we have in the picture, we have magnesium oxide and calcium hydroxide. So these two substances react with acids to produce salt and water only. Alright, next we have example of alkali. So the example of alkali, when sodium hydroxide pellets is dissolved in water, sodium ions and hydroxide ions that can move freely in water are produced. So here the statement shows that the substance can be soluble or dissolved in water. So it is called an alkali. Alright, also an alkali is defined as follows: chemical substance that ionize in water to produce hydroxide ions. Right? So as you can see in the picture, this is the definition of alkali. Alright? And then what will happen to ammonia molecule when ammonia gas is dissolved in water? Why is aqueous ammonia produce an alkali? So the answer is, by dissolving ammonia gas in water, aqueous ammonia is produced. Aqueous ammonia is an alkali because the ammonia molecules ionize partially to produce hydroxide ions.
Citrus fruits such as oranges, lemons and grapes are sour. These fruits taste sour due to the presence of acids. These acids are also found in foods such as vinegar, tamarind and tomatoes. For example, vinegar contains acetic acid, tamarind contains tartaric acid and tomatoes contain oxalic acid. Acid can usually be identified as sour-tasting substances. We also find substances that exhibit properties which are almost chemically opposite to acids. These substances are called bases. Soap, detergent and baking soda are some of the common bases we find in a household. Let us try to understand these substances in detail. Arrhenius theory. In the year 1884, Swedish scientist Svante August Arrhenius introduced a theory on acids and bases. He defined acids as those substances which release hydrogen ions or H+ ions when dissolved in water, and bases are those substances which give hydroxide ions or OH- when dissolved in water. Bronsted and Lowry theory. In the year 1923, Johannes Nicolaus Bronsted and Thomas Martin Lowry proposed another acid and bases theory. According to their definition, acids are proton donors and bases are proton acceptors. Lewis theory. Gilbert N. Lewis, an American physical chemist, introduced a new concept of acids and bases. He defined acids as an electron pair receptor and bases as an electron pair donor. Identification of acids and bases. When a blue litmus paper is dipped in acid, the color of litmus paper changes from blue to red. When red litmus paper is dipped in a base, the color of the litmus paper changes from red to blue. Phenolphthalein turns colorless in acids, whereas in bases it shows a pink color. Methyl orange in acids gives a red color, and in bases it gives a yellow color.
Alright, next is the uses of acids, bases and alkalis. So acids, bases and alkalis are not just chemical substances in the laboratory, but they are also widely found in daily life. For example, toothpaste, which is alkaline, functions to neutralize acid on the teeth. And then we have vinegar, is an acidic substance used to make pickled chilies. Alright, for additional information, acids only show acidic properties in the presence of water. When an acid is dissolved in water, acid molecules will ionize to produce hydrogen ions. The presence of hydrogen ions allows the acid to show its acidic properties. Therefore, blue litmus paper changes to red. Without water, solid oxalic acid C2H2O4 only exists as molecules. Hydrogen ions are not present. Thus, the color of the blue litmus paper remains unchanged. Alright, for alkalis, the alkalis only shows alkaline properties when they are dissolved in water. Without water, hydroxide ions in the sodium hydroxide pellet cannot move freely and are still tied in its lattice structure. So the pellet of sodium hydroxide does not show alkaline properties. The red litmus paper cannot change color. When a pellet of sodium hydroxide is dissolved in water, hydroxide ions are produced and able to move freely in water. Thus, sodium hydroxide solution shows alkaline properties. Hence, the moist red litmus paper turns blue. The presence of water also enables ammonia gas to ionize and produce hydroxide ions that are responsible for its alkaline properties. Therefore, the moist red litmus paper turns blue. Without water, ammonia gas only exists as molecules. Hydroxide ions are not present. So, red litmus paper remains unchanged. Alright, so let's proceed to the next slide. What is pH scale? Alright, pH scale, which range from 0 to 14, is used to show the acidity and alkalinity of an aqueous solution. Solution with pH value less than 7 is acidic, while solution with pH value more than 7 is alkaline. Universal indicator pH meter or pH paper is commonly used to determine the pH value. Alright, so what is actually pH? In chemistry, pH is a logarithmic measure of the concentration of hydrogen ions in an aqueous solution.
In the year 1909, a Danish biochemist, Søren Peter Lauritz Sorensen, introduced a scale to measure acidic or basic strength known as the pH scale. The scale runs from 0 to 14. The pH of acidic solution is less than 7. pH of alkaline solution is greater than 7. pH of neutral solution is 7. If the solution is more acidic, the pH will be very low. If the solution is more basic, the pH will be very high. pH is defined as the negative logarithm of hydrogen ion concentration. pH occupies an important place in our daily life, such as our digestive system has pH. Excess gastric juice produced in our stomach can be neutralized with antacids. pH change leads to tooth decay.